students, your voice is beat a bit low. If you can check your mic, if you can be a bit loud.
Uh, so I think my voice is clear, right?
Your voice is clear. It's bit low, so maybe if you can be increase your voice.
I think I'm having a full volume only. Let me.
Okay.
Yeah. So students, I need to hold my mic. Okay. So students, I'm thinking like what is measure, what is column, how you are creating a calculated column depends on your usage, and you know how to clean your data on like a Power BI desktop or on Power Query editor. And then if these topics are covered, the next topic is like filters, slicers, okay, how you are filtering the data on the particular given diagram or else on the particular table given. After that, you might be seeing your data having multiple dimensions. So then the complexity of the data will be increasing. So then how you are handling this complex data means by having the schema-based architecture. So we are having like, can anyone tell me how many types of architectures, schema-based architectures are there? Can you show me? Can you tell me what are the schema names you came across, and what are the schemas which you have used till now? So I'm expecting some answers from you students. You are 260 students are there. Yeah, star schema. Okay, star based means a star schema. Okay, snowflake, star. Okay. So did you use these two of? Okay, galaxy is also there. Yeah. So did you use anyone like for your data handling? So did you use anything? Did you use any schema till now? Or else are you going by the same? Okay, not yet. Okay, got it. I think measures are covered. Okay, very nice. Not yet. Okay. So measures are covered, calculated columns are covered. So only thing is schema-based architecture. Okay, no problem. I'll be covering today, and I'll be giving you a simple scenario how like star schema is useful, snowflake schema is useful, and all. Okay, so got it. So now we are having a few schemas. So that if the data size is increasing, so how to handle this data? But if I go by the same single file, it will not give me the all the dimensions. So retrieval time will be more. So that is the reason I'm just for convenience and for speed and accuracy, I'm converting the data in a single sheet or single flow into multiple tables. So that table, multiple tables are there. So why schema comes means here, when the multiple tables are there in my data. Okay. Then we need to go and find the appropriate schema for the multiple tables. Again, the question, why multiple tables are required? Suppose when you are handling a simple student data, like consider only for today's attendance. The business scenario is only for today's attendance. So what is the tables dimensions I need to mention? Maybe the columns are serial number, student name, and then date and mark your attendance. So all these things can be covered very simple in a single sheet. Suppose when I want to have the student record basing on credits which they generated, they secured in first year, second year, third year, any supplementaries are there, any special achievements are there. So any bridge courses he has done, NPTEL courses has done, bridge seminars like this undergone, any publications he has done. So this complex data I want to maintain. So maintaining this much complex data, it's very difficult. Okay, so that is the reason I'm going by the multiple tables. In all multiple tables, so I can use the student name or the roll number as a first column. Okay, and then I am correlated whenever the what is the particular X student achievement means, I'll pull all the data from all the tables. Okay, so this is what we are doing. Okay, this is what we are doing. Yeah. Now, my question is that is can be done manually, but when you are using the data analysis using Power BI or any business intelligence tools, so how you are handling these multiple tables? So that to handle these multiple tables, okay. So I'm having three schemas. One is star schema. Second one is snowflake schema. Different schemas I'm having. The simplest architecture is star schema. Okay, I'll be showing you why it is simple, the advantages, the disadvantages of the star schema. So the star schema is by default option for multiple tables to integrate together, and then Snowflake, and then Galaxy. So in order to understand all these three different types of schema architectures, I need to understand the terminology for schema. So the terminology is involving in few terms. So the first term is okay. So these are the few terms. Okay, just to go through this. So whenever typing, I think students, I'm just why you are getting this voice low means sometimes I'm just typing. So when I'm typing, you are getting a little voice down. Okay, so please adjust. So I just made my settings from my end. Okay. So now see here. So dimension table, fact table. Okay, these are the terminology which we are understanding to understand the schema-based architectures. So now like dimension table, fact table, primary key and foreign key. So let me understand what is the dimension table. Okay. So this is simple table having different columns on a business problem statement. Okay. And this particular table, dimension table is having one numerical column or one categorical column where by identifying that you can identify the entire row. Okay. So like a student name, that is dimension table. And the particular dimension table, we are having a particular key to understand, like the same key will be there in other tables also, so that you can able to track the same student in all the tables. Okay, so that particular column maybe in terms of numerical values. Okay, that particular column I am calling as primary key. Primary key is just nothing but a particular column using which I can able to identify the details of the same student across the different tables. Okay. So when you are not having any dependency, then that is called as dimension table and the column is called as primary key. So the dimension tables are having primary key. So just I'm mapping here. You can see here. I'm just mapping here. Dimension tables will be having primary keys. Primary key is nothing but the column. Okay. So using which I can able to identify the dimension or the student details. Now we are having another table like fact table. Now what is the meaning of fact table? So let us consider I want to have the sales transaction of a particular person, okay, in a supermarket. This is my problem statement. So now I need to go and see the sales register. Once I see the sales register, I can see the name of the customer and the product which he purchased, the rate at which he purchased, and the discount, the net sales, and all the things will be there. Now, please tell me in these details, in the sales register or sales total table, which columns comes under like a dimension table and which columns under comes under different tables. Like I'm giving the scenario here. So I am going by sales analysis. I need a sales table. Okay. In the sales table, what are the columns I may come across in a supermarket? Can you tell me the column names? Can you tell me the column names? I want to analyze the sales in a supermarket. Customer ID, customer name. Yeah. Yeah, I'm just writing. Yeah, correct. So I'm going by customer ID, customer name, the product purchased, the product purchased, MRP, discount, net sales. Okay. Now please tell me. So these are the columns which I need. Okay. So now where from these two columns are fetching from? Do you expect all these columns will be there in a single table? All these columns will be there in a single table? Yeah, product ID is there, product name, product ID. Yeah. So these are the columns. So we are not expecting all these columns from a sales table from a single table. Not necessary. So not necessary means it should not be. It should not be. Okay. So now I need to fetch, okay, these columns from different tables. Yeah. I got it. Sahil, I got it. So please tell me now, please tell me like which columns I am taking from which table. Which column I'm taking from which table. ID, like customer ID and customer name. I am taking from customers table, right? These two columns, first two columns, ID and name, I am taking from, yeah, customer table. Yeah, very good. Yeah, Chirag. Now, product ID, product name, and the product name purchased. The category comes under, the subcategory comes under, all these things, product related information, where it is coming from. Very good, Harsh. Product table. Okay. So this MRP, okay, discount and net sales, where it is coming from? This is regarding the pricing. MRP, discount, net sales. Price table, or else we can consider as a inventory table. Okay, order table, inventory table, or another table, right? So now we came across, yes. So we came across different tables together. So now, whenever a sales transaction has been initiated, we are pulling this data from different tables. It is very convenient. If you keep all these information in a single table, it is very difficult to organize. So that is the reason we are going for star schema. And this is the example for the one problem statement. So now instead of keeping all the data in a given single table, I am organizing the data in multiple tables like a customer table, one product table, inventory table, or another table like this. So now to save your time, okay, to save your time, I'm just going by uh, star schema. Okay, let me take you to the star schema images. So I'll be explaining simple explanation regarding star schema. So this is the structure. Can you, I think you are able to see, right? So this is the structure. Okay. Oh God. Let me open another one. Okay. Okay. So now you can see this is a star having different like nodes here. Okay. Each node will be representing a table here. Okay. One table at the top, another at the second node, third node, fourth node, and fifth node. When a, and one node is one table is there at the center. So the tables can be categorized into two different categories. All the tables which are at the end or edges of the star are called as dimension tables. Okay, where it is having the native information. Okay, and now one table is there at the center of the star. This is called fact table. Now, what is the meaning of this fact table and dimension table? So here, each dimension table will be having its own agenda, like sales and customer table. Only it is speaking about the customer, serial number, customer name, customer ID. Only it is speaking about the customer only. And we have another table like product. Only it is speaking about the product category. Okay, it's not something else. And we are having another table. So it is speaking about their own dimension. So it is not speaking about anything. But here, if you see the central table, which is at the center of the star schema, so it is having like fields, like the fields coming from different tables, different dimension table. Okay, I'm taking few columns from customer table, few columns from product table, few columns from inventory table, few columns from feedback. Okay, all these things we are taking and we are pulling in a particular a particular table. That a particular table having the access to all the dimension tables is called as fact table. Now, how it is integrating? My question is like how this fact table is integrating, is pulling the data from the dimension table. We already know that dimension table. Yeah. So one answer is given. The fact table is the main table which contains every dimension table. It's not every dimension table. I think you are seeing that my screen. Yes, sir. Can you able to see my screen, students? Yeah, yeah. Okay, okay, got it. Thank you. Thank you. So now, how these two tables are integrated? So for each table, there will be a primary key. Okay, primary key means it's a column, mostly a numerical column, which is identifying its rows uniquely, like a serial number, student number, or customer ID number, like bank account. So these columns will be there. So now every table is having a numerical column or a primary key. So using that primary key, I can able to identify the row uniquely. That particular column I am giving in the central table. Okay. Now the central table using this primary key as a reference to access the table information. So then the particular key in the particular central table is called as foreign key. So it is a foreign key for the central table, but it is a native key for the dimension table. So as long as the column is there in the dimension table, that particular column I'm calling as like primary key. When the primary key or the primary column is mapped to the central table, fact table, then the particular column or the particular key is called as foreign key. So I'm just pulling all the foreign keys from different dimension table according to my business problem statement. So once the problem statement is identified, and if I pull all the foreign keys from different dimension tables, so now this table can access the data from different tables, different dimension tables. So this table is having access to all the things. Whenever the requirements comes, it is pulling the data as per the requirement. So this is called as fact table, and these outer peripheral, these tables are called as dimension tables. And we are coming across two different keys. One is the primary key, which is there in the dimension table only to identify the rows uniquely. And we are having another key called as foreign key, which is there in the fact table and which is used to pull the data from the selected dimension table. Did you understand up to this? Yeah, Anuj, Anuj, can you get it? Can I repeat it? Anuj, can I repeat it or can I move ahead? So the dimension table is just not. Yeah, data modeling. Yes, I want to show you the data modeling now. Correct. So we're going for, yeah, joins. Yes. Yeah, Anuj, thank you. Okay, we'll be discussing everything. Okay. So now let me go for, this is a star schema. It is occupying like the nodes of a star. So that is the reason why it is called a star schema. Okay, in the star schema, please try to understand. So can you see the screen? This is called as snowflake schema. So now what is the difference between this star schema and the snowflake schema? Can anyone tell me? I think my screen is shared. So can you see my screen? Yeah. So it is visible. Thank you. Now please tell me anyone what is the difference you are seeing between the star schema table and this is the snowflake schema. So there also we are having one fact table. Here also we are having one fact table. And now if you look at the dimension table, okay, in the star schema, I'll be showing you. This is the dimension table in the star schema. So every node is having single dimension table. The dimension table is not further split into different dimension table. Only one dimension table will be there. That dimension table is getting connected to fact table through the primary key. Now, if you look at snowflake schema, you can see here the fact table is connected to the dimension table here, and the dimension table is further divided into another dimension table. You can see here two dimension tables are there. So if I can combine these two dimension table, it will be coming into single dimension table. But why we divided into one dimension table into two dimension table? Can anyone tell me this? Why it is done? Why it is done? Yeah. So one dimension table is connected to another dimension table. Yes, correct, Aryan. Why? Why it is done? Can you tell me any reason for that? Why one dimension table is further divided into multiple dimension table? Okay. For more clarity. Yes. For more clarity. Yeah. Very good. So one person told reduce the redundancy. Darshan. Yes, very nice answer. For reducing redundancy. So what is the meaning of redundancy? Let us consider. Okay. So this particular single dimension table is having like a product tables. Okay. The product table is having like this. So product ID, product name, and product category, product subcategory, MRP, like the amount of investment, investment. These columns will be there. Let us consider like data redundancy. So in the category, I'm having 1,000 products in the table, and a few products will be there under electronics category. Okay, and few categories are there under office supplies. So that means here for all these 100 categories, the same category is keep on repeating: electronics, product number one, electronics, product number two, electronics, product number 100, electronics, product 101, it is office supplies. So like this, the same name is keep on repeating. So when the same name keep on repeating, do you find any challenge in this? If the same category or if the same subcategory is repeating multiple times in a table, do you find any problem with respect to this repeating? Yes, yes, yeah. Efficiency, load reduce. Yeah. So here, when you are having the same name, okay, if it is repeating again and again, first problem is the data will be redundant. That means the same data will be repeated. To save that particular data, we need saving the more memory is required. Again, the complexity is involving. Again, the clarity is missing. So this is the challenge whenever you are having the redundancy in the data. Now, if these challenges are there, how to overcome these challenges? Can anyone tell me how to overcome these challenges? I want to reduce the storage space. So when I can reduce the storage space, I can increase the speed. I can increase the clarity. I can decrease the load. Now, how can I convert into like the redundancy into non-redundancy for the tables? Can anyone tell me? I given the scenario like I'm having a product table having different product IDs, different product names, and different categories, different subcategories. Now, how can I divide this into now? So let me give you the scenario also. I'll be telling you the tables also. Okay. So I'm having product table. So in this product table, I'm having product ID, product name, and then category, subcategory. Okay. So these are the columns. Now, can you anyone tell me? So if I'm maintaining the product table like this, do you find it is useful? If the small amount of data is there, if you are right, if you are having a business problem statement for a particular smallest business, so there is no problem. It will not consume much data. So it is very simple to extract the data. But when you are running this particular table for a big organization like a Reliance, okay, Reliance Smart or so, okay, DMart. So this product is having a lot of big table. So in that particular scenario, so the category is most of the times will be repeating. The category will be same for different hundreds of products, and subcategory will be same for hundreds of products. So I am taking out, okay, this product category and subcategory and keeping in a particular different table that I'm calling as category table. Whenever I need the category, I am pulling the data from this product table from this category table. So then it is called as, so then I'm calling this as one dimension table. Give me a second. One second. Okay. So now I'm making like category and subcategory into a different table. Whenever the requirement comes, only then I'm pulling this particular table. So now when I'm keeping this subcategory and category in a separate table, I need not repeat. Okay, I need not repeat the category like electronics 100 times and then office supplies 100 times. Only one single entry will be there. That same single entry will be pulled many times as and when required. So this is the clarity sake or modularity sake or to avoid the redundancy or to save the time and for making it more complex, like more convenient. Yeah, we need unique identifier for each table. So then you can easily combine the two tables. Okay. So that is called as whenever the complexity of the data increases, and in the complex data, whenever the redundancy is increasing, then we are moving on to star schema, from star schema to snowflake schema. Did you understand? So that is the reason why you are getting this particular diagram. You can see here. So now here, this dimension, the top dimension table is not having the redundancy. So that is the reason it is directly connected to the, you can see here, fact table. The dimension table is directly connected to the fact table. Now at the right side, one dimension table is split into two. So why? Because the dimension table on the right side is having more redundancy. So that is the reason we went for splitting the dimension table into two, and the two dimension table will be interacted by the same mechanism, foreign key. Okay, now the dimension table having one for a primary key, and that will become a foreign key for the dimension table 2. And once the fact table is calling this first dimension table which is there on the right, it is in turn is calling the another dimension table from its foreign key. So this is how the dimension table which is there at the bottom. Can you see? One dimension table is there between fact table and the dimension table. Can you see here? Yes or no, students? So this dimension table which is sitting between the fact table and the dimension table, how it is acting like? Can you tell me the behavior for this dimension table which is sitting between fact table and dimension table? Students, make it fast. We need to cover the visualization also today. What is the role for the dimension table which is sitting between fact table and the dimension table? So the dimension table which is sitting between fact table and dimension table is acting like a dimension table for the fact table, and the dimension table which is sitting between the two tables is acting like a fact table for another dimension table. So that means here the dimension table is working like a both. Yes or no? The dimension table which is sitting in between the fact table and dimension table is working like a fact table sometimes, and sometimes it is acting like a dimension table. This is all depends on the complexity of the data. When the data is having redundancy, so you can able to organize the data without any redundancy for clarity sake, for saving the for saving the memory and for speed and all. Okay, now this is the read. Did you understand up to this? Students, make it fast. Yes or no? Okay. So now, yeah, thank you. So now we are going for another schema. So what is the schema we left with? Galaxy schema. So now if I go to the galaxy schema, now if I go to the galaxy schema, how the dimension tables, okay, all these things are related. Now we can see here. Okay, now you can see. Now this is a galaxy. Okay. So now the galaxy schema, you can see here, there are till now, we have seen only one fact table and only the fact table is getting the data centralized. So now you can see many fact tables are there, many dimension tables are there. Again, depends on the complexity of the data, redundancy of the data. Each dimension table can be split into multiple dimension tables. So all these multiple dimension tables are integrating to their fact table, and we are having multiple fact tables. One fact table is dealing with the few dimension table, another fact table is dealing with the another dimension table. So when you are having the complex data architecture, so to get the clarity, to get aware of redundancy, to save the memory, to increase the speed, so we are going for snowflake schema, or else we are going for galaxy schema. So now when the data size itself is very small, so then we are moving on to star schema. Okay, so let me go to up to this. I think it is clear. I think depends on the redundancy and the complexity of the data. We are moving on to like star schema to snowflake and snowflake to galaxy. Yes or no? So now, yeah, thank you. So now I am going for the Power BI. So let me open the Power BI. This is my Power BI empty. Okay, nothing is there. So now I want to add the particular scenario, business scenario, where I'm coming across different types of tables like dimension tables and fact table. So now I'm having a particular table. I'll be sharing you also. So for the time being, so let me share you that also. So I'll be showing you the dimension see here, sales data modeling. So when you see the sales data modeling, we are coming across different types of tables. You can see here. We are having locations, okay, location ID, location name, one table. And we are having category ID, category name. We are having customer ID, customer name. We are having customer ID, location ID, category ID, sales amount. Now, how to call this particular table, which is popping up right now, this table? How to call this table? Is it a dimension table or a fact table? You can see here. The schema is, the columns are looking like this. What is the name of this table? Is it a dimension table or it is a fact table? Student, make it fast, make it fast. Yeah, fact table. Yes, correct, fact table. So that is the reason it is taking the data from different tables using their primary keys like CID, customer ID, location ID from location table, category ID from category table. And then we are calculating the total sales amount for the particular customer. So this is called a fact table and the remaining are dimension table. So I'll be sharing, no problem, I'll be sharing this. So now this particular concept of connecting all the tables together, I'm calling as data modeling. So the name of this particular process is called as data modeling. So now we are going for data modeling in Power BI. So just go to this Power BI. Okay, now go to Excel workbook. You might be knowing how to add the data to this. Importing, you might be knowing. So I can go to Excel and I can able to identify. I can go to the particular table and select the table like this. You might be knowing how to import Excel table, all numerical values in the fact table, always here. That depends on, again, our wish. Like if I want to create the customer name also into my total invoice, like I can add it, no problem. It is not always rule that only the dimensional keys, foreign keys only we are expecting in the numerical values. The rest of the things will be in the numerical, like categorical, like name of the customer, name of the product, okay, all these things. So now you can see, I'm going for how many dimension tables are there? So these are three dimension table. One dimension table is speaking about the category. Other dimension table is speaking about the customer. Other dimension table is speaking about the location of my business. And this fact table is collating all the information by connecting with them through their foreign keys or primary key of the dimension table. So just give me 1 second. Just load it. Just load it. No need to click on the transform. So when you are clicking on the transform, when you are clicking on load, can I get answers? When it is expected to click on load and when can I expect to click on transform? Okay. So can anyone tell me? Let me close this. Let me close this. Yeah. For transform, when you click on the transform, you mean your data is not cleaned. But when I'm clicking on load, I mean that data is as of now. Maybe the cleaning process will be done after loading also. But for the time being, I don't want to clean it. I know my data. So that is the reason I'm clicking on load button. Yes. So now, so the data has been added. You can see here dimension table, dimension like 3 dimension tables, 1 fact table. Now, if I want to connect all these things, go to the right hand side. You can see report view. We can see table view. We can see model view. So just click on this. Okay, model view. By default, why these by default all these tables are integrated together? These two you can see here. Fact table is integrated to the dimension table. Why? It is not integrated to the other tables. Why? So we are having another tables also. These two tables are not connected, but dimension table by default it is connected. Can you tell me why? So this is called the interaction, like the combination, like modeling is done between the fact the sales table and the dimension category table. Yeah. Column same surname. Very nice, Sahil. Because you can see here when I hover like my mouse on the relationship between the two tables, you can see here. So two columns are popping up. One is on left side, other one is on the right side. You can see on the fact tables, category ID is there. On the dimension table also on the right side, category ID is there. Whenever by default the same names of the columns are mentioned, so by default the Power BI is identifying these two columns are same and it is by default it is connecting. Okay, so this is like by default it is connected. Now I want to manually correct these two tables also. Let me connect dimension table with respect to customer. How can I connect this? Can anyone tell me? How can I connect these two? Yeah, it is the primary key. Yeah, column names are same. Now, between fact table and the dimension customer table, the column names are different. Now, how can I connect this customer dimension table to the fact table? Yeah, so we need to make a connection basing on customer. See, customer is not customer name. I told you like a foreign key or dimension like primary key should be same like numerical values. Mostly we are taking the numerical values. So customer name is not that one. Yeah. So now you can see here customer ID is a numerical one and in the fact table CID is just nothing but customer ID. So now because the same names are not there, so it is not able to identify the table. There is no relation. Now see here manually I am dragging this customer ID and dropping onto the CID part. Now here you can see here it is popping up. The relationship is popping up. Okay, now you can see CID is having 1, 2, 3. Okay, in the fact table. Okay, and then category ID is also having 1, 2, 1, 2, 3, 4, and so on, so forth. Now the cardinality between the two tables, the relationship between the two tables is 1 to many. 1 to many. That means here, what is the meaning of this? 1 to many means what is the meaning of this? When the cardinality between two tables, one dimension table and one fact table is 1 to many. What is the meaning of this? One entry in the dimension table is identifying multiple entries in the fact table. That is the meaning of this. So let us consider one customer for a supermarket comes on one day and he purchased a pen in the morning. Again, the same customer with the same ID, same name, he purchased a book in the afternoon. Again, the same customer comes into the evening and he purchased one laptop. So that means here at the end, So in the fact table, you can see multiple entries on the same person, like same customer, having the same ID, same name. But the entry in the customer table is single. Only one ID will be there, one name will be there. So that is the meaning, like when the dimension table to the fact table, we are having the cardinality relationship between one to many, means multiple entries in the fact table. Yes. So he's buying. Okay. Okay. Multiple actions. So he's buying and he's again coming and it is he is refunding. Okay. He don't want to like take the product. He want to refund it. So like that, we are having multiple entries in the fact table. So that is the meaning of cardinality. Cardinality depends on the again the interaction between the two tables. The cardinality will be one to one sometimes, one to many sometimes, many to one sometimes, many to many. Depends on the like data redundancy and the complexity of the data. Okay, did you understand? Yes or no? The cardinality relationship, there are four types of cardinalities are there. Okay, thank you. So now I'm just, I know the data. So I know dimension table, I know the fact table. So I mean customer ID from the customer data table is just nothing but CID table in the fact. So just I'm dragging and dropping here. So when I'm dropping here, it is popping up this relationship. So it is going for one to many, no problem, no problem. Okay, just click on save. So it is identifying the relationship type. It is identifying the relationship type. So it is having one to many. Now you can see here. Now here, see, uh, this dimension table, like customer table, is integrated with the fact table. And you can see here, one on the dimension table, star on the fact table. Can you see, students? Yes or no? Sometimes one dimension table is having one, the number one, and the star is there. What is the meaning of this? One means, yeah, one means, yeah, one too many. Yes, correct. Yeah. So one means we are able to identify one unique number of times, like the particular customer ID is repeated in the customer table. But the same ID is there multiple times in the fact table. So that is the reason why star always means many. Star always means many. And in the above category also, like categorical table and fact table, we can see one to many. So that means here, this dimension table and fact table are integrated together by what? One to many cardinality. Okay, just I'm just hovering like this. Okay, now I am going by this location. So let me adjust. I want to make it as like a star. Okay, right. Now, so how to connect location table to the fact table? A dimension location table to the fact sales table. So which columns are common? Which columns? Location ID. Yeah. So location ID, I'm dragging and dropping onto the location ID in the fact table. And here also you can see like one to many, no problem. That means that is what in general in business, all business application, this is the same like expectation we are doing. Most of the times, like 99% of the times, like dimension table will be having single entry and the fact table is having multiple entries, so that it will be having the cardinality like one to many. So now you can see here, this is something like this. So this is something like that. Now all these dimension tables are integrated to the fact table through their primary keys. So the primary key location ID in the dimension location table will be coming as location ID as the foreign key. And same way, the category column is having category ID. This is the primary key, and now it becomes category ID in the fact table. That is a foreign key. Like that. So by primary key and foreign key, we are integrating all the dimension tables in the fact table. So this is comes under star schema. So once the star schema is identified, that means all the four tables are integrated together. Whatever the question you are mentioning in the problem statement, now it is able to answer it. It is able to answer it. Let us consider, like I'm going for a pie chart. Like let us consider, I'm going by the pie chart. So the pie chart is expecting some legend and some values. Okay. So I am taking the legend from like category name, suppose say. So this is a category name. So you can see here, there are the four different categories are there. ACs are there, books are there, mobiles are there, televisions are there. Now I want to know the sales amount, the consolidated sales amount for each category. Now you can see here. Now here, can you see? So like how many tables are giving me the answer? My question is for this particular pie chart, the question is I'm keeping the question, the problem statement. The problem statement. Okay, so here sales amount, total sales by each category. Okay, this is the problem statement. So, like if I want to analyze this particular problem statement, I am taking a pie chart. As you see, I am taking a pie chart. With the pie chart, I am able to identify the total sales for each category. But how many tables are responding here in this problem statement? Is it a single table or a multiple table? Students, so now the multiple tables. The primary key is already we integrated together, right? So I'll be showing you the same primary key will be there. Every time the primary key will not be changing. Once it is connected, okay, through primary key and foreign key, the relationship will be static. So it is taking the data from all the tables. So let us go back. Okay, there are multiple tables there. So now you can see here in the dimension category name. The category name is there in the category table. It's a dimension table. Now the primary key is category ID. You can see that is not changing. I'm just pulling this particular column name as per my requirement. This ID will not be changing. The category ID is the primary key as long as it is there in the dimension category, and the same category ID will be the foreign key in the fact tables as long as the relationship is existing like this. So that when the relationship is existing, so when I'm keeping my hover, if I hover my mouse like this, the ID will not be changing. The foreign key will be remain same. The primary key is also remains same. It is not changing. Only thing is I'm just pulling as per my requirement. I'm pulling my data. So to my satisfy my particular business requirement. So now you can see. So is it done? So the multiple tables are integrated together. So whatever be the problem statement, now I'm making, so multiple tables will be responding. For in this case, I'm just going by two tables only. Okay, one table is fact table, other one is dimension table. So like that, if I am having a problem statement which which deals with like six tables, can we do it? I'm having a problem statement, a real-time problem statement where I need to get the data from six tables. Okay, can I do it? Can I do it? Yes or no? Yes, we can do it. So how can you do it? Without data modeling or with data modeling? How can I do it if I'm having multiple tables, okay, spread across all my database? Can I take it without integrating them together or by doing some data modeling? Yeah. So we are doing the data modeling. Yes, correct. Yeah, path. So we are doing the data modeling, and the data modeling, once it is done, it is very easy to define a problem statement. All the tables, okay, which are related to the particular problem statement will be responding, and finally we can get a beautiful chart like this. So this is called visualization. It is very clear, very easy to visualize what is the category, books, and total sales for each category, like books, okay, and then ACs, and then televisions, and then mobiles. It is very easy. So when you are converting, so I'm just asking you one simple question. When you are converting the text data into like charts or graphs, what this procedure is called about? When I'm converting the text data into charts and graphs, first thing, why I need to convert the text data? Because that, anyhow, you are we are going for the charts or graphs only from the text data. Text data is available in the like tables. But why we are converting the text data into charts again without taking the data directly from the text? Again, we are wasting our time creating the charts and explaining the same process to all the stakeholders like business people, like my chairman, my supervisor, my co-supervisor, my customer. Okay, why we are converting the text data into charts and graphs? Please respond. Because easily understood. Yes. So mostly, like whenever you are doing a business, let me take you the different scenario. So whenever you are doing any business, okay, we will be having so many stakeholders. So many stakeholders will be there. Okay. So let us consider your CEO, your chairman, okay, your manager, customer, suppliers, etc., etc. So these are all the stakeholders for your business. Yes or no? So now, yeah, okay. Understand the business very easily. Yes, correct. So now these are the stakeholders. Now please tell me, like you also, like I will be adding your role also, because your role is what? Your role is what? Students. Our role is what? Our role is data analyst. Yeah. So these are all the different stakeholders. Now, my question is, why data analyst is required for the businesses? Why the data analyst is required as one of the main stakeholder? This data analyst is a third party person. He nowhere investing the amount into the particular business, and nowhere is buying the product and returning the product or doing the sales. Nothing. He's not buying any single product. He's not investing the money into the business. He's not doing anything, but he's doing some different thing. What is the business here? What is the role of this data analyst now? Why he is hired into the business? He is not the member of our board of members. He is not the member, and he is not the customer. He is not the supplier. Even then, he is playing very important role. Yes, correct. Chirag, very nice, very nice. So the answer is, like, these stakeholders are there na, who are putting the money. Okay, the end user buying the particular product. They are not comes under technical part. They don't understand the technicalities on the data. So only one person is there having the technical knowledge, data analyst. So he is having the technical knowledge. So that means here, what is the meaning of this? He can read the text data. He can read the text data very easily. He's having the like particular knowledge, how to read, how to understand, how to take the decisions from the insights produced from the text data. But these other stakeholders are there now who are actually running the business. They are not from technical. They are not from the technical. They are non-technical. So now for them, this particular data analyst or business analyst will be coming into the picture. He is converting the huge text data into very simple graphs and charts. Now, these charts and graphs will be very, very useful for any non-technical person to understand. So that is the reason why we require what? We require what? Visualization. Okay. So for what? We require visualization. Yeah. So now visualization in one single sentence, just nothing but converting the text data into visuals or graphs so that any non-technical person can understand very easily what is happening in their business. And what is the use of this visualization? Okay, they will be understanding what is happening in their business. So what is the advantage of understanding this? What is happening in their business? Now, what is the reason behind this? Why they need to understand? Can anyone respond? Why they need to respond? Why they need to understand for future growth? Okay. So one way it is correct. Yeah. So for understanding their business. So visualization is making them to understand their business, what is happening inside their business. But why to understand means, like, to take, this is very important, to take data driven, this term is important, data driven decision. So to take data driven decisions. So why we need to take data driven decisions only? Why not by experience? Why not by expertise? Why not by our like mindset? Why we are not taking the decisions not on the experience? Earlier days, like 10 years back or 15 years back, all the businesses are running on experience. One senior person will be there in a business. He will be dictating. He will be suggesting all the things, what to do in the business, what not to do in the business. But nowadays, when the data availability is there, no one is going and referring the old experience. We are all taking the data, we are processing the data, we are visualizing the data, we understand, and then we are start taking the decisions. So this process is called as data driven decision. And why it is taken? Is it effective or it's not effective? Data, yeah. So yeah, data means, yeah, it is effective. Yeah. So it is very, very effective. So the data, I'll be defining what is the meaning of data. So data is always speaking about the facts. It never lies. It never lies. That is the reason. So that is the reason. So I'm not using the data. So there are two types of data there again. One is raw data. Okay. Raw data. And other one is what? Other one is called cleaned data, cleaned data. Now, for the first time, whenever you see the data for the first time, it is called as raw data. Raw data means data is there, but I don't know whether the data is having the facts or not. Now, what is the meaning of fact again? So, did you understand this? Raw data, the first time whenever you are seeing any data, that is called raw data. You are not sure about the quality of the data. You are not sure about the quality of the data. Again, the question comes, what is the quality of the data? I think students, can you able to follow my way of teaching? Is it comfortable to you? Okay, I need few responses, students. Yeah, thank you. Yeah, no, no, quality of the data. So when I'm talking about quality of the data, so just for the time being, just leave about raw data and clean data. Finally, I need quality of the data. When the data is not quality, the outcomes, the final results after visualization also will not be qualitative. So we are not taking decisions on in-quality data. So that is the reason we are converting the raw data into quality data, cleaned data, or structured data. So now what is the meaning of quality data? Can anyone tell me what is the meaning of quality data? So whenever the data is following 6 dimensions, ACC, TUV. Just remember these are the 6 dimensions. ACC, TUV. Data, any data, whether it is raw data or any other data, wherever it is following these 6 dimensions, then the data is said to be highly qualitative data. So what is the meaning of this first A? Can anyone guess? ACC, TUV. Accuracy of the data? Yes. Yeah, yeah, I'll be coming to the outliers, anything. I'll be coming to there. Okay. Wish, like for explaining you more clearly, A stands for accuracy of the data. Okay. Accuracy of the data. Now, what is the meaning of C? This C. Completeness of the data. Okay. Completeness of the. Next C. The second C. Yeah, consistency. Very nice. Very nice. Consistency of the data. No, this T stands for what? Timeliness of the data, right? U stands for what? U. No, it's not transparency, timeliness of the data. Okay, U and V. Uniqueness, yeah, very nice. Okay, I'm just taking out your answer. U is nothing but uniqueness, right? Correct? U stands for uniqueness of the data. Uniqueness of the data means again, without any, without any uniqueness of the data means what? Without any duplicates, without any duplicates, uniqueness. Okay. The what is the V means? It's not visualization. I'm talking about validity. Yeah. So validity of the data. Correct. Validity of the data. So whenever you see these 6 dimensions like accuracy, completeness, consistency, timeliness, uniqueness, and validity of the data, then this data is called as highly qualitative data. So when you use this highly qualitative data, you will be getting highly qualitative output. So when you are having a highly qualitative output, you can use this highly qualitative output for your visualization, for your data analysis. And once the data analysis is conveyed to your all stakeholders, they can take the decisions very, very easily. So that is our role as a business analyst or a data analyst. Okay, our role is to make them comfortable the way they understand. So that way we are explaining, we are cleaning the data. So for achieving this dimension, these 6 dimensions, so we are taking the raw data initially and we are cleaning the data. So for that only, for cleaning the data only, we are having one provision in Power Query, like Power BI. So that is called where you are cleaning the data, where you are cleaning the data. So we are cleaning the data in Power Query Editor. So that is the reason why Power Query Editor is there in the Power BI. So using Power Query Editor, you can clean the data so that your data will be following all the dimensions like ACC, TUV, and then you're making the data qualitative, and then we are using the qualitative data for our like business application for taking the business data driven decisions. So then only the data is called as facts. When you are not cleaning the data is not speaking the facts. When you call the like when you clean the data, then only the data is called as facts. And the other name for the data is called as, what is the other name for the data? Is called as information. Information is different and the data is different. So data maybe sometimes it is speaking about the raw data, but information, when I'm saying information, it is it is a clean data. It is following all the 6 dimensions. It is always speaking about the facts. So then it is called as information. I think up to this it is clear, right? The data modeling and the data dimensions. I think the of my mic. Okay. I think it is clearly audible now, right? Hello. Okay, okay. So now, did you understand up to this? So till now, I discussed about data modeling, why it is important, and what are the types of schemas we are encountering and why. And then the 6 different dimensions for data cleaning. Yes or no? Up to this? If you understand this, now we'll be moving on to the next topic. Chirag, yeah, thank you. I need few essays, few responses. So we are having 326 people here. I need few yes, a few no's. Like if you don't understand, I'll be repeating. So we'll have student make it fast, make it fast. So I need to cover today a complete visualization. Yeah, done. Okay. So thank you. Yeah, clear. So now I am going by. Okay, I'm just using sample superstore. Okay, let me open that. So now, since you understand the data cleaning part, why multiple tables together need to be considered, all these things you might be knowing. The next concept is visualization. Okay, now my role is here is to convert the text into what? Visuals. I want to convert the text into visuals because the text is very difficult to understand for the non-technical stakeholders. So we are converting the entire text into visuals in terms of charts, pie chart, graphs and all. So now there are 2 types of visuals are there. Again, the one is standard visuals. The second one is what? Custom visuals. Okay. So there are 2 types of visuals are there. Standard visuals. Okay. Custom visuals. Let me take you to the Power BI. So can you see the Power BI now? Yes or no? Can you see it? Yeah. So now whatever be the visual under visualizations tab, we are having so many standard visuals are there. Like one is bar chart, okay. Other one is like area chart. Other one is like card. Other one is like matrix, table, okay, slicer and all. So these are by default. These are free and these are comes with the Power BI desktop. So these are called as standard visuals. Only standard type of visualization only eligible here. Suppose my requirement, my problem statement, my business requirement is different. Like, let me give you one different scenario where these standard visuals may not give me the exact output what I am aiming for. Can you tell me any one business scenario, students? I may not use these standard visuals which are there in the Power BI for free, may not be sufficient enough for visualization of my my way. I'm thinking in a different way. Can you give me that particular business scenario where these standard visuals may not provide me the correct output, expected output? Can anyone give me one business statement where standard visuals may not give that much accurate output? Anybody? I'm just waiting here for 1 minute. I'll be moving on. Okay, let us consider one scenario. So for that, I'm just opening. This is the particular sample superstore. Very simple data set I have taken for the visualization. So like order date is there. You can see ship date is there. So many columns are there, right? So now I want to know like customer name. Can you see the customer name here? Can you see? So see how many columns, how many rows are there, how many columns are there? So many thousands of rows and thousands, hundreds of columns are there, right? Yes or no? Can you say this is a simple data or a complex data? Is it a simple or a complex data? The student respond fastly. It's a complex data. Very nice, very nice. So no. So this is a complex data. Now my business statement I'm giving you, like I need a customer name which is repeated for many times, highest number of times. This is the problem statement. I'm just typing here my problem statement. So the problem statement, I need customer name, customer name who bought max times, maximum number of times. Okay. So I need a customer name like this. Now, how can you get this customer name who bought for many times, hundreds of times from this text data, from the same text data? And these are the columns. You can see here, column customer name is also there. So how can you do it? Which particular table, which chart you are using? So there are multiple charts are there, na? In the Power BI data, we are having so many standard charts are there. Can identify just by unique customer ID. How can you identify? That is what I am expecting for. How you are able to identify it. Okay, so let me take you to this. I can solve this problem in two different ways. Well, you can answer it, no problem. If I wait for one more time, 1 more minute, you can answer. But I'm not having that much time, so let me go to another chat. Like go to the another chat. Like I'm going for the stacked bar chat. So this is the stacked bar chat. Now I'm dragging. Okay, so I'm dragging this customer name and the sales amount. You can see here. Okay, now, okay, this is a category name, like customer name. I need customer name. So my customer name is in customer dimension table. Now you can see here. Can you see the screen, students? Who is the first customer who bought for highest amount? Can you able to see? Jane. Very nice. Very nice. Now, he is my top customer. He is my top customer. Now, because I'm running a complex business. Yeah, correct. I'm running a complex business. Okay. I don't want to identify single customer name. I want to identify 100 customer, top 100 customers. How can I able to do it? I want to go for top 100. Single customer means you can easily identify which is comes under at the top. That is like a top customer who bought for highest amount, highest number of times. But I don't need it. I don't need it. Can you tell me? There is a glitch. There is a glitch. Can you categorize Jane as a customer who purchased for more amount or purchased for more number of times? How can you know it? Jane is a customer who purchased for more amount or like multiple times he visited and bought many times. How did you understand this? Did you understand question, students? I want if purchase is greater than x, then fetch name ID. Okay. Okay. You can't understand. So now tell me here. So here there are two ways. I want to know the customer name. I want to know the customer name. It is, remains same. Okay. I want to know the customer name. First one is by total amount purchased. Total amount purchased. How much amount he purchased in my business. That is one way to identify the top customer. The second way is by how many number of times he bought. How many number of times he bought the products. Okay, not using the line chart. It is not helpful in the line chart. Okay, how many number of times he bought? Sometimes let us consider Jane is a single customer. and he made this total amount. So let me take the amount of Jane also, 45,000. So total he bought for 45,000. He came once, only for single time only he came to the shop and he purchased the one TV which is costing around 45,000. He never came to the our business again. Maybe he's not the right person. Okay, now I want to identify the customer who is, no, please tell me who is the loyal customer between these two. A customer who purchases for more by visiting less number of times, or a person who is always coming and buying small amounts on many times. Which is the best way? Who is the best loyal customer? Always coming. Yes. Yeah, second one. Very nice, very nice. So now this is the loyal customer. Now, whenever I want to identify my customers, I will be identifying by loyalty. So now I need to go by the second one. Now, this chart is good enough or not? Can I use this chart? Or else do I need any other? No, this chart is not useful. Yeah. So now I need to go for one more chart where this number of times, basing on the number of times, I can able to identify. I'll see here, I can modify this like a stacked bar chart also. See here, can you see x-axis here? In the x-axis, instead of sum here, if I go by count, you can see here. Okay. Now I'm going by count, count of sales. Here, I'm just removing this. I'm going by the sales amount. So not by sum, not by count. Now see here, for the count also, Jane visited for 5 times and Johnny visited for 4 times. No, this way I'm having many customers here. It is very difficult to identify all the customers. In the real-time complex business, many customers will be there. But it is showing what is the limitation for this particular chart, all the standard visuals. Can anyone tell me? What is the limitation for all the standard visuals? What is the limitation for the standard visual? We cannot represent the complex real-time scenario. So that is the reason. Now you can see here. That is the reason I'm going to identify another type of visual that is called custom visual. Did you understand why I'm going for standard visuals? Why I'm going for custom visuals? Did you get it or not? There is a difference between these two. Yeah. So now I am going to identify. See here, the standard visual sometimes fail. It cannot give you the accurate output which you are aiming for. Now we are going for custom visuals. Let us go back to the Power BI. Now, how to import the custom visual? So in the visualizations pane, so you are having 20 to 30 standard visuals. Now there is a 3 dots here. Can you see these 3 dots? If you click on these 3 dots, you will be getting get more visuals. Just click on these more visuals. Now see here, I register myself for the Power BI. You can see here on my Gmail ID. So I am connected to my account here. So after that only this more visuals will be connected to the custom visuals like this. So these are all different custom visuals. So let us go by a simple visual. For this requirement, I am going by word cloud visual. Word cloud. The name of the visual is word cloud. You can see here. Yes or no? Can you see word cloud? Yeah. No. Yes. So now I am just adding. I'm adding this visual. Okay, by clicking on single click on the word cloud visual. Now you can see it is loading that particular things. Now word cloud, it is explaining what is the meaning of word cloud. You can read it. Okay, you can read it. So after reading, so the output is looking like this. Sometimes one particular word is getting more size. Sometimes we are having less size. That means here in the entire data, so the term like social is repeated for many times. Now when I see this particular diagram, okay, when I see this particular diagram in the earlier version, which is more suitable, instead of giving single, it is also having the relativity. I can able to identify after social, the next word which is highlighting in the given data is media, and then networking, and then content, and then information, and then so on and so forth. That means it is very easy for the real time. If I want to change my dynamics at the runtime. Instead of going by the standard visuals, going by the custom visuals will be very, very handy. So now after reading this, I'm just clicking on add here. Add button is there. Now you can see under visualizations pane. Okay, import was successful. Now can you see this word cloud visual here? It is added to visualizations pane. Yes or no? Did you see? Yeah, yeah. So now I am using this. Now click on this back to report. Okay, now click on this word cloud visual. This is the word cloud visual. Now I am dragging the customer name here. Okay, now you can see here. And by sales amount. And sales amount is not by sales amount, but by count. Now, please tell me which is more convenient. So Jane is there, Johnny is there, something is there. Which is more convenient? Using the standard visual or using the custom visual? Which is more convenient? Like standard visual means like a stacked bar chart. Okay, and the other one is by using word cloud. So you are having standard. Okay, so because the data itself is very small, so you are having both the things are very relatable. So now I am going by the realistic. Like let me go for blank report now. Now we are moving on to sample superstore. I think you are all having the sample superstore data set, right? Yes, sir? No, students? Yeah. So just import the sample superstore. Just import sample superstore onto Power BI. Now do the same activity. I want to know the customer who is repeated for many number of times because this is a real-time data set. Now I'm just adding. Can you guide me, anyone, like how to add? How to import the data set, which is of Excel data source. Sample superstore is Excel type data source. Now I'm having only single table. It is not that multiple tables are there. So just simple for visualization understanding. So I'm using a simple table, having single table. Okay. Just click on import. Students, can you able to follow with me? Yes or no? Just open a new tab and try to load or try to import sample superstore data set to Power BI. Yes, yes, Yuvraj. Thank you. Thank you. I'm just closing this. I don't require this. I want to go by the real-time data set, sample superstore. So now can you see the orders is there? I think not much data cleaning is required because the sample superstore is already cleaned. If you want to extract any feature engineering, so then only you can do it, feature engineering. Otherwise, it is quite good. So now, what is the meaning of feature engineering? Can anyone tell me what is the meaning of feature engineering? What is the meaning of feature engineering? The sample superstore, the data set is 100% cleaned. No much cleaning is required. 99.99% it is clean. Much cleaning is not required. But whenever you want to go for feature engineering on the cleaned data set, then we are loading the particular data set into Power Query Editor, and then we are doing the feature engineering. Feature engineering means depends on our business requirement. Sometimes we are creating a new column from the existing columns. That is called feature engineering. Yeah. So let me check your answers. Raw data, meaningful. Okay. Yeah. Converting raw data into meaningful insights is nothing but visualization. Okay. Now feature engineering means let us consider I am having purchase date. Okay, one column is there in the sample superstore. So the customer is purchasing his products on so and so date. That column is called as purchase date. It is there. It is there already. You can see. So where is this? Like order date. You can see here order date. Order date is the date on which the particular customer purchased. So it is having Date is there, month is there, year is there. Yes or no? Yes or no, students? Yeah. So now my question is, I'm already having an order date, but my manager is given the problem statement like total sales. My manager is asking the problem statement as year wise total sales. Now, do you have year as a column in the data set? Do you have the year column in the data set directly? Yes or no? I am having order date as one of the column. Yeah, converting the date column into the like year column. So that is called as feature engineering. So depends on our business requirement. Sometimes we need to create a new columns, depends on the requirement. So that is called as feature engineering. Okay. So I think you got it. What is the meaning of feature engineering? But today, like in the morning session especially, I don't want to go for feature engineering. I want to show you at least what is the meaning of visualization. I'll be going by few problem statements and I'll be asking you to convert the text into visuals. So in the afternoon, I'll be going to the feature engineering. Okay. Again, I'll be going to the custom visuals. Again, I'll be going to the standard visuals. Again, I'll be going for some controls, like controls in terms of selecting the selected data using filters, slicers. Okay. And then we are demonstrating you in terms of bookmarks. Okay. So controlled navigation from one page to the other page, how to save, how to share. These things I'll be discussing in the afternoon session for the time being. For the timing. Did you understand what is the meaning of feature engineering? Yes or no? Past students? Yeah. Yes, Sahil. Thank you. Yeah, thank you. So now I'll be going to the Power BI. No, I'm not going for the feature engineering. Afternoon, I'll be going and doing the feature engineering. So now I'm having orders table. In this orders table, I'm having so many columns like this. Okay. Now my first requirement is I want to identify the total sales. So my first business problem is I want to identify total sales. How can I identify? So we are having the sales column. I'll be showing. Let me close this. Okay, let me go to the Power BI. Do you have the table view? So this is the table view, right? In this table view, if you look at the columns here, we have the sales column. We have the sales column. Yes or no? We have the sales column. Now I want to add all these values which are there in the column, Now how can we add it? And how can we convey this is the total sales happened till now? Okay, right from the row number 1 to last row to all my stakeholders. How I can do it? Can anyone tell me? How can I do it? You need not do, I'll be doing from my end. Only tell me the idea. How can I get the total sales from sales column? Anybody? Yes or no? If you know, if you have the idea, say yes. Otherwise, say no. New measure. Very nice. You have the DAX. You know how to create a DAX measure, right? Very nice. Making new measure, right? Very good. So again, measures are two types are there. Implicit measures are there. Explicit measures are there. Okay. Yeah. So might be you knowing sum because the last student responded with sum. That is called explicit sum. Okay. Now, so I'm just selecting, okay, table tools here on the top. You can see I'm just selecting sales column here and I'm clicking on table tools here. So on the table tools, you can see new measure is there, new column is there, new table is there. So I'm just clicking on new measure since most of the students know this DAX part, the basic DAX. So now I'm keeping the name as total sales, total underscore like sales and is equals to sum function I'm doing. Sum is a basic DAX function. Sum, divide, okay, these things. Add. So sum, in this sum, you can see it, I need to provide the column name here by syntax. In the syntax form, I need to provide the column name here. So by automatically, we are having only one table. So now all the columns are popping up here. Which column you are selecting, that your wish. Okay, now I am selecting because my ambition is to calculate the total sales. I'm just selecting total sales here. Now you can see orders is the name of the table, and within the square brackets, whatever be the name is there, that is called column. In the orders table, I'm selecting sales column. Just close this, enter. Just close this and enter. Now you are having total sales column, a total sales measure created. Now you can see total sales at the bottom. Okay. Now I am going to the report view back. This is my report view. Now, if I want to visualize, okay, the total measure, like a total sales measure, which visual is good enough? Which visual is good enough? Yeah, which visual is good for showing the total sales value, like pie chart or which one? Donut chart, card. Oh, yeah, bar chart. So the best visual to represent any number is that is using card visual. Yeah, card. So just click on the card visual. This is my card visual. Okay. So just drag this measure, total sales created, that measure, drag it and drop it. That's it. So now you can see 2.3 million. Okay. Maybe dollars, maybe rupees. It is not mentioned in the data set. It is not mentioned. Okay. So now can you see 2.3 million? Yes or no? So this is very comfortable. Okay. Now looking into the afternoon session. If I'm keeping the same card visual like this, it is not doing anything. So I need to make it more interesting by adding some background and colors and everything like conditional formatting and all. So that I'll be seeing in the next like afternoon session. So for the time being, this is 2.3 million. Okay. So now for the timing, yes or no? Do you know formatting of the visuals? Do you know formatting of the visuals? Make it fast, make it fast. We are having only 20 minutes. Yeah, formatting you'll be knowing. Yeah. So now please tell me, I'm going quickly. I'm going for the formatting here. I'm changing. It is having a specific name. Build visual. No. I'm just asking. See, I'm just zooming it. So here in this card visual under this number 2.3 million, we have a text total sales. How to call this total sales? This is called is not the title. It is the label. Now I want to remove this label. I want to keep title. Title will be at the top. Labels will be at the bottom. So now in the formatting, so just click on this format and then go for label. Label by default it is on. So make it off. Now see here, the label is off. The label is off. Now I want to keep it title for this. Okay, visual, card visual. Just go to the call out value. Just expand this. Okay, just expand this. Okay, now you can see all the display units. Suppose if you want to change the color, font, everything, you can change it. Now click on this general tab, general, and now activate this title. Now the title is on. Now you can keep the title like total sales. Okay, total sales. By default, it is there on the top left corner. So that you can able to format it. So I want to have the middle alignment. Okay. And then some effects I need to have. Effects means background color. So the background color, again, the background color depends on the requirement. Okay. So you can go and select manually from this, or else from more colors also you can able to identify, or else you can, if you are having the particular hex color, hex code for any color, you can add it automatically. It will be updated. Otherwise, you can go for view and you can select few already standard formats will be there. Okay. So according to our business requirement, that you can able to select. So I am going like this. So let me select city park. One theme is there. Okay, just select city park. Now I am not allowed to change multiple colors. By default, some standard colors will be there. I'm just selecting those colors. Now you can see here. Okay, now here I want to go for like let me go for, yeah. So effects. So in these effects, okay, background, I want to change from white. See here, many colors are not able, and I'm not having the access to the many colors because I have selected the theme. Under view, I have selected one theme. So I'm maybe comfortable with this light color. So this is the thing I want to say. And see, when I'm seeing this color change, no, I am not able to see the total sales. So for that, so I need to go for, okay, I need to go for text. I'll be doing that again. So let me complete this background. So if you want to change the transparency, you can see here. The transparency, you can change it. When you drag it, a light color will be there. When you close to the 0 degrees, 0%, the color will be somewhat thick. Okay. So make the visual border on. So the border is activated at the around the visual, and make the shadow to on. Now you can see the shadow is keeping generated. Now I want to go and change the total sales so that everyone can see it. Now for that, so I'm going for the title here. Okay. Now change the color of the text color of this to something like blue color, something like this. The blue color is not good, so I'm going by the black color. So now this is good. Now I'm keeping bold, and I'm keeping something like a font size as 20. Okay, middle alignment. Now this is looking good. And now I'm just adjusting here like this. And now I'm keeping. So this is a little formatting I had done. Okay. Suppose if you want to change 2.3 million, I don't know million. Suppose let us consider your stakeholder doesn't know million. So I can change this value also. Again, select this card visual, go to formatting. Okay. Go to call out value. And now display units instead of auto. Okay. Now you can go for none. None means no value will be given. So the actual value will be there. So this is 22 lakh 97,200 rupees 0.86 paisa. Suppose if I want to remove this 86 paisa, okay. So now the you can see here value decimal places under format. So just keep zero here. Just keep zero and enter. That's it. Now it is automated to the it is aggregated to the next possible interest integer. So now this is without any like units, like it is million is not there, billion is not there, thousand is not there. So like this, when you are comfortable, just select this, go to the format your visual, go to call out value, just change visual to millions. That's it. Okay, so this is a visual. Suppose you might be knowing like, sir, like last time we got a 08. I want to get back this. So then you can delete this. Okay, now you can see it. This is total sales. So you can adjust it. Okay. So is it clear, students? Yes or no? Yeah. So I need few responses, students. You are having 318 students. I need few responses here. Yeah. Thank you. Thank you. So now, shall we go for another problem statement? Now my problem, total sales has been done. Okay. Now total profit. In the morning session, I'll be going by all the chord measures, chord related, total profit. So, and then total profit, and another one is only one I don't want to make you more trouble, so I want to take total sales, but there is a condition. Okay, what is the condition? I want to know the total sales for like one category. So this total sales, we are adding all the rows of a data set, but no, I don't want to add all the rows of the sales column, but I want to specifically go and identify for what category this total sales is there. So let us go by the like data set. Now, what are the like categories are there? So if you are having the O column, if you see the O column, you are having the categories. How many categories are there? Can anyone tell me? How many categories you can see here? Three. Yeah, three categories like furniture, office supplies, and technology. Now my manager is asking me to identify the total sales only with respect to the furniture. So there is a condition, right? Now my manager specifically was asking only furniture, only for furniture category. Now here I am updating the problem statement now. Total sales for furniture category. Furniture category. Okay. So now we are going to these three visuals here using card visual. Okay. Can anyone tell me profit? Is there any change? Or else the same? Only the column is the only difference. Instead of sales column, we are going by the profit column. Yes. Yes or no? There is no rocket science now. Instead of sales column, we are going by the profit column. Yes or no? I want to get total profit. Yes. Okay. So now, yeah. So now I'm going to the Power BI. Okay. So I'm again no, this is explicit measure. So explicit measurements, you can see the measure name. So the total sales is the measure name. This is called explicit measure. Yes or no? Now I want to go for implicit measure. Implicit measure means I don't want to write the DAX measure. Even then, it is possible. So now go to the card visual directly, created card visual, just adjust it somewhere. And now see here, total profit column is there. Just drag it and drop it onto the card visual. That's it. We are not writing any formula. So this type of measure, you can see here sum of profit. So we are not writing the sum DAX function, but it is created by default. This measure is called as implicit measure. Did you understand? There will be manually we are writing some DAX function and we are creating the measure for that particular calculation. That is called explicit measure. Sometimes we are dragging. Power BI itself is understanding the context and it is able to create the measure. That is called implicit measure. Yes or no? Which is more convenient? So that will be seen in the afternoon class. Okay, that will be seen in the afternoon class. So now, like students, I'm giving you a simple context. So since total profit is also there, I want to can I go for a different color, different formatting for this card visual, or else the same formatting is required? Let us imagine you are working as a data analyst. You are working as a data analyst in a given company, X company. Do you want to go and visualize in a different colors for different visuals, or else any rules or regulations will be there for the given X company? Rules and regulations will be there. Yes. So now for the particular company, there will be a standard formats will be there. You need to go by the same rules and regulations. Now my question is here, I want to go and do the same formatting, because understand, formatting is not a simple thing. There are many rules and we identified so many things added to the card visual, but remembering that many setups, that many adjustment, it is very difficult. Correct? Yes or no? Remembering each and every adjustment we made for a visual, it is very difficult. Now I need a mechanism where I can copy and paste it on the different visuals, so that the first formatting, whatever be the sets or whatever be the way we done for the first card visual, that will be copy pasted for the remaining visuals. That automatic way I am adapting now. So can anyone suggest me how to copy and paste the formatting for first card visual to the second card visual? No, can you see my screen, right? Can you able to see my screen, right? Yes. Format painter. Yes. So it's simple. I want to copy the first card visual formatting to the second card visual. I don't want to waste my time again and again. Okay. Since my company is expecting the same standard visuals, same standard colors, same type of standard formats. So whatever I done till now, by spending some 5 minutes or 6 minutes, I'm just copy paste onto the second card visual also. Just select this card total sales, go to home, and there is a format painter is there. Just copy format painter and come to the particular visual. Okay, just select this visual and single click. That's it. Now automatically this is done. Now see here, the same color, the same formatting. So we are not wasting single minute. So automatically it is updated. No, some adjustments will be there. What is the adjustment I need to do in the second card visual? Students, yeah, title. So it is not, by default title will not be on for the card visual, so only that particular thing I need to activate. So just selecting the second card visual, go to format painter. Okay, just for format your visual tab, and then go to general, just make the title to on, and now give the title. So the title is, I'm giving the title as total profit. Now you can see the same format, the same size, the same bold color, the same different things. So it will be there. So now you can adjust it. Okay, and just KPIs. These are called as KPIs. Remember this. What are these two in a business language? These two are called as what? Students. These two are called as, what is the name given to these two card visuals? In every dashboard, every business dashboard, these two card visuals will be there. You can refer anything. KPI, very good. So yes, part KPIs. So these are this should be there. These KPIs. There are many KPIs are there. We'll be using that KPIs also. Okay, no problem. So these two card visuals, we are representing the basic KPI. Now I am going by the next one, the condition one. Total sales is done. Total profit is done. Now I want to go by the total sales for furniture category. So sales is there, but I want to go for furniture category. Now for this particular requirement, is it good enough for going by the implicit measure, or else I need explicit measure? How can I implement this? How can I do this? Total sales for furniture category. I need to go by. Sir, how can you explain again how we can give same visual? Just copy paste. Just copy paste. I'll be showing you again. So now by default Power BI is adding. So I'll be showing you again. I'm going to I'm going to card visual again. So this is my card visual, the third card visual. When I'm dragging the sales column, and I'm getting 2.3 million as similar to the previous first card. But the first card is explicit and this is implicit. Now, I don't want to go for total sales by adding all the values in the column, but I need only the values defined under furniture category. So here, the implicit measure fails. So that is the reason why we need to go for understanding, creating the explicit measure. Okay, understand why we are going for implicit, why we are going for explicit. Explicit is making us convenient to define the conditions on the computation. You are going to calculate total values by some DAX function, but there is a condition involved that you cannot do it on implicit measure. So I am going to the explicit measure. So go to dashboard. Now I'm just removing this for the timing. So I'm going for, okay, table view. Go to the table view and select the table tools, and now click on new measure. So this way of creating the measure is called as explicit measure. Now I want to go for total sales for furniture category. Did you understand the name? Okay, total sales underscore furniture. So now I am going to calculate one function. Which function I need to use? Any student, any idea? Any idea? I'm going to use the function, the DAX function called as calculate. Calculate, within the bracket, the first parameter is expression. Expression means I need some expression on sales column. Just go by the same. Okay, I can go for sales column. Okay, sales column, I can select this. Okay, this is total sales. You might be saying yes or no. The same expression is there in the total sales also. Yes or no? Yes or no? Yes. So, sir, you can say like, sir, we already done some on sales column, it is already explicit measure. It is already there in the Power BI. So why can't you use it? Yes, I can use it. Now see here, I am just removing this. I am just removing this. Okay. Now already total sales is there now. Now I'm calling this total sales. The total sales is also having the same meaning. Yes or no? The total sales explicit measure is also there. So instead of writing the expression again, I'm just calling this total measure in another measure. So this is the use for writing explicit measures. So I can use once the explicit measure is created, it is like it is portable across all different other measures also, all different pages also. So that is the advantage. So I'm just calling the total measures here. Now I'm defining the condition here. So the condition is the category should be okay. Let me define total sales, and now I'm going for category column. Okay. So now how can I give the category column? So when I'm typing the name of the column like category, it is already showing here at the bottom. You can see here at the bottom. Order stable category is equals to in the single quote. Okay. What will be the category? Furniture category. Let me type it, furniture category. So that means just put this and just enter. Okay, now this measure is created. I can show you. Can you see total sales underscore furniture? Student, yes or no? Yeah. So now this is for only furniture category. Now I'm coming back to the visuals here. I'm just copying here. See here, I'm just copying this. Someone asked. So I want to copy this card visual and paste it. Control C, Control V. And now I want to keep it here. So this I need to modify it. How can I modify? This value is not this is just for furniture category. I'm just removing all these things like call out value. Okay. I want to go and the first thing is I'm changing the title here. Total sales, total furniture sales. Okay. Total furniture sales and the value is there. So that value, okay, that particular value I should understand. Okay, let me take you to this. Okay, first let me complete this. Total furniture you updated, right? So now this profit column I'm just removing. Okay, I'm just removing this profit column and now adding my required data. Total furniture, total sales for furniture category. Yes or no? Just adjust it. Suppose say if you're not able to adjust, so I can decrease the font size also. So the font size you can decrease here. Instead of 27, you can keep it 20. Let me see. Okay, this is okay. So now I want to go for title and then make it to title to something like somewhat less. Okay, something like 18. 18 is done, right? Yeah. So if it is not 18, like 16. Now you can see here. So even if it is not suitable, so then you can go to like general and you can go to titles. You can decrease that to 10. So like that, you can able to do it like total furniture sales up to this. Is it clear, students? So how to implement condition based calculations? Yes or no? Yeah. So yeah. So this is called conditional formatting. I'll be telling you the conditional formatting again, okay, in the afternoon. So we went for only using card visuals. And in the card visuals, we've seen two, like implicit measures, other one is explicit measures. Again, in the card visuals, we've seen without conditions and with some conditions up to this. So in the afternoon, I'll be taking standard visuals. I'll be taking custom visuals for each problem statement and try to design one like interactive dashboard for this sample superstore problem statement. Okay. Yes or no? Is it convenient for the afternoon session? today in the afternoon, we'll be trying to complete the visualization part by taking the sample superstore dataset. Yeah, thank you. Thank you. Okay. So any doubts means, yeah, thank you. So we'll be discussing, I think, in the last half an hour in the afternoon session. Yeah. So thank you, students. Yeah, thank you. Others, others, are you there? Okay. Students, shall we leave? Shall we leave and assemble back again in the afternoon at 1 p.m.? Okay. Yeah, thank you.